Find the general solution for x in the equation sin x minus sin 2x equals 0. You can ask yourself, where do I start with this? Don't be scared to start. One possibility is to say that sin x equals sin 2x, because now I have a sine ratio which is equal to a sine ratio. Remember, we can't just divide by cos of some angle, because these two angles are different. But what I can say now is that x is the angle that I want to solve, and that I see the 2x on the right hand side as the reference angle. And now I work where sine is positive, and that is in quadrant 1 or 2. In the first quadrant, x will be equal to 2x plus multiples of 360 degrees, or in the second quadrant, x will be equal to 180 degrees minus 2x plus multiples of 360 degrees. If I solve here, I get negative x equals multiples of 360 degrees, which brings me to x equaling multiples of 360. In this part, I get that 3x is equal to 180 degrees plus multiples of 360, and now I must divide everything by 3. Therefore, x equals 60 degrees plus multiples of 120, with k an element of the integers. However, there is an alternative way to look at this problem. You might have seen immediately that sine of 2x is a double angle. So you might rather write sine of 2x as 2 sine x cos x. But in the next step we see that these two terms, there is a common term, sine of x. Factorize, and there will be 1 minus 2 cos x in the brackets, and of course this equals 0. Remember, don't divide by sine x to remove it now. What we will say now is that sine x equals 0, or the bracket 1 minus 2 cos x equals 0. Now remember, where is the sine graph equal to 0? It is at 0 degrees, at 180 degrees, and at 360 degrees. Or if you look at the negative side, at minus 180 degrees, etc. So we can say that sine x equals 0 at multiples of 180 degrees. What we will get on this side is that 2 cos x equals 1, therefore cos of x equals a half. When I calculate, using my calculator, second function cos of a half, I get 60 degrees. So in the first quadrant, x will equal 60 degrees plus multiples of 360, or in the fourth quadrant, x will be equal to 360 minus 60 degrees, which is 300 degrees, plus multiples of 360. With, of course, k being an element of the integers. When we look at the black answer up here, and then the blue answer down here, it looks like two entirely different solutions. Let's test if they're not perhaps the same. Let's make ourselves a specific solution, and we'll say that we want the specific answer of these two equations in the interval 0 to 360 degrees. This means that I have to fill in values for k, which will give me angles that fall within this interval. So x will be an element. If I make k 0, it's 0 degrees. When k is 1, it's 360 degrees. And I can't go further, or I will be outside the interval. In this equation, if I make k 0, I get 60 degrees. When k is 1, it's 60 plus 120 degrees, which gives me 180 degrees. and if I make k 2, then it's 240 plus 60, which is 300 degrees, and that is still within the interval. And so those are the angles that lie within the interval. Now let's do exactly the same with the blue equation. If I make k 0, I get 0 degrees. When k is 1, I get 180 degrees. k2 gives me 360 degrees. And here, if k is 0, I get 60 degrees, and I can't go further, then I would lie outside the interval. And here, if k is 0, it'll be 300 degrees. Can't go further, otherwise it'll lie outside the interval. Compare these two solutions. Can you see that they are exactly the same? Here is another equation which we must find the solution for. When I look at the equation, I notice a few things. I see that here is an angle 2x and here x. I would like these angles to be the same. Another thing I see is that here is a constant. What I'm going to try to do here is to see if I can change the equation to a quadratic equation, which I can then solve through factorization. If I look at this cos 2x, I'll have to use a double angle formula to replace cos of 2x. Cos double angles has three possible formulae. But if I look at the rest of the equation, there is only a cos. So I suspect that I should use this equation, because in this equation there is only a cos present. And this means I won't have a sine or a sine squared in the equation at all. So let's replace the cos 2x with 2 cos squared x minus 1, and the rest of the equation remains the same. In the next step, when I multiply out, I get 4 cos squared x minus 2, which gives me, along with the other 2, a 0, and all that is left is plus cos x equals 0. So now I do have a quadratic equation that I can factorize by taking out cos x as a common factor. 4 cos x plus 1 remains in the bracket. And this implies that either cos x equals 0 or that the bracket 4 cos x plus 1 equals 0. Cos x equals 0. Let's look at a cos graph to see where cos is equal to 0. Where is cos 0? Cos is 0 at 90 degrees and again at 270 degrees. If we write this as a general solution, then we will write x is equal to 90 degrees plus multiples of 180 degrees. And on this side, we get that cos x is equal to minus a quarter. Our reference angle here, second function cos of a quarter, is equal to 75.5. Where is cos negative? Cos is negative in the second quadrant or in the third quadrant. In the second quadrant, we find that x is equal to 180 degrees minus 75.5, and that gives me 104.5 degrees plus multiples of 360 degrees. Or, in the third quadrant, x will equal 180 plus 75.5, which gives me 255.5 plus multiples of 360 degrees. And we must of course remember that this is part of the answer and this is the rest of the answer. And for all, we need to say that k is an element of the integers. The alternative to cos x equals minus a quarter is second function cos of minus a quarter on my calculator gives me 104.5. So I can write this immediately as plus or minus 104.5 degrees plus multiples of 360 degrees. Then plus 104.5 is the angle that lies in the second quadrant, and minus 104.5 in the third quadrant.